Hello guys, today I'm going to show you how to create basic auto park project with Arduino. This is wiring, how to do wiring. This sketch is explaining that. I will dive in this later. Firstly, I will go to the code and explain the code. So this is main like .ino file. In here we include the needed libraries like Arduino.h, that's always needed when doing Arduino, of course. Servo.h, because we are using servo for the gate to open and close. LED, this is library that I have created. So we're using LEDs for showing whether the places where the car will park, whether it's active or not, busy or not. So there's light sensor. This is actually called photocell as well, and light resistor as well. So it's detecting how strong is brightness of the light. So we need that as well, because we will use that for when car parks. It will detect that the car of the shadow will send a that will make shadow, and the sensor will drop the value of brightness so we can understand there is a car. Okay, so these are the needed libraries. Now we have here objects. So firstly there is LED, so red LED and green LED, as in here, red LED and green LED. Light sensor, LDR, yeah, and it's called LDR as well, so it's this one. Distance sensor, we have distance sensor as well. That's for distance sensor is for when car comes near the gate in front of it, the sensor will send us that the value of distance is shorter, so we can know the car came there. Actually, motion sensor could be used as well, maybe, but I have decided to use distance sensor. So we need distance sensor. Its model is HCSR04. It's here, okay. So, and we need servo for gates. Now let me explain you the libraries that I made for like LED, light sensor, distance sensor, and servo. Well, servo is not mine, sorry. So firstly, we have like main, like template of classes, like how we make classes. You need to do this. You can actually look up on internet how to use classes in C++. So this one needs Arduino H as well. So here are protected variables. Protected variables mean that when you create an object here like red LED, you cannot access to these variables. Only this class and the classes that inherit from it can use these variables. And public means that everyone can use. I mean, you can use, if you inherit, you can use, and you can use if you make like an object, and you can just access as this sensor, let's say, or LED. Well, it's here, red LED that set pin, so you can just access these from anywhere. So in protected, we have pin of the LED and state. State is whether it's on or off. So this is a H file. You just you just define here variables. You initialize them in here in constructor, and this is constructor. I will not explain what constructor is. You can look that on Google. You can Google it. It's related to object-oriented programming. There's set pin, get pin, turn off, turn on, toggle, get state. Okay, so set pin is, well, it's obvious. It's setting pin. So the LED will, if you set pin to 5, that means that your LED needs to be on 5th pin on Arduino. So so that it works. Get pin is get pin is used if you want to know if you're not sure what the pin is of some LED. You can use get pin so you can see what its pin is. Turn off, and turn on. Turn on is to turn the LED on, and turn off is to turn it off. Toggle is every time you call toggle, while the LED is off, the first time it's off. So when you call toggle, it will turn it on, and when you call toggle again, it will turn it off. Get state is to to see if it's on or off. If it's on, it will return 1. If it's off, it will return 0. So let's dive in that CPP file of LED class. So in constructor, I set that pin is -1 because I want whoever uses this class, I want him to set pin. I don't want to have any default pin here like 3, because maybe he's using something on 3rd pin, so that would be actually bad. And state is 0 by default. So here's how setPin class function works. SetPin function. So it says like mpin is equal to pin that he passed in function. So now this variable will become what he passed to the function, like 3, let's say, and this is needed if you want to use like pin. You need to say LED. You need to say that 3rd pin is output, and you can look up that at Arduino help how to use LED. And here is get pin. It's just return pin. LED turn on, digital write, and pin high, so it turns on the pin that is set. Like right now it's 3 in our example. And state 1, so it says like state is turned on, so the LED is turned on, so the state is 1, true. And turn off is like it's just turns off, sets that pin to low, and sets the state to be 0 because LED is off. Toggle, well, now let's say we call toggle first time and first time first time we create the object, mState is 0 because we initialize it in constructor to be 0, so it's 0 first time. So when he calls toggle, now it will become opposite of what it was. So if it was 0, now it's 1. I turned on. So mpin. Now we set the pin to be in this case on because it was off, and if it was off, the state if it was on, then state would become 0 because opposite of 1 opposite of true is false, so mState will become false, and then it will set the pin on low. You can actually, I didn't tell you that, but you can, instead of writing low or high like I did in here, you can write 0 for low and 1 for high. Just keep that in mind. And get state is simple as much as get pin is. You just return the variable's value. So now we understand how LEDs class works. We created red LEDs object and green LED object. Now I will explain you light sensor. So in light sensor we again have Arduino.h, and by the way we need Arduino.h here because we are using like pin mode, digital write. These are all Arduino libraries functions, so we need Arduino library. Now we define here previous values count. You can look on internet what define is. It's something really easy to understand in C++. I will not really explain now. Protected, again we have pin, and here we have environmental brightness. So I will show you in a moment what that means. Again we have constructor, set pin, get pin. So let me firstly show you how these set pin, get pin, these are a bit of different than in LEDs. So this is the same. You set pin to be -1. I will explain this later. And set pin, well, in LED we need to say pin mode, while in light sensor we don't need to say pin mode because it's reading from analog pin. So this LDRI light sensor is working on analog pins. You can Google it. There is like an explanation in details about sensor. So it doesn't need pin mode to be set. I just wanted to show you the difference. Okay, so environmental brightness is, so we set it to be 0 in constructor. Again, I want him to set the environmental brightness. It is for sensor to when the program starts. My program is when you put your Arduino project, let's say in a room that is a bit dark, then he records the brightness of the room, and when the car comes, again it will be a bit of difference. So because he recorded the environment brightness of the room, he can now know how much did it change, so it can detect whether the car came or not. If you set this to be some constant value, it wouldn't work on in every room. If your room is more brighter than other room, it wouldn't work in all rooms. So I will show you now how the other functions work with that environmental brightness variable. So read, well, read is just analog read, and the pin, you can Google analog read. It's just returning value from the analog pin that is returning value. So it is, so it just returns this. And we have here setter and getter. It sets, this one sets environmental brightness. It's very simple. and this one returns it. And here we use this is the formula for understanding whether the car came or not. Get status actually returns if status of sensor changed in a way like in a big way. If car came, then because the shadow of the car will close the sensor, it will be much darker. So this get status will return 1, meaning that status changed. If it can be 1 even if car moves back from the place, so the light will come and it will be more, the difference from the last value will be more, so it will return 1 because it changed. So the duty of this function is to return whether the status changed in a big way. Okay, so I will explain the function now. Oh, sorry. So absolute abs is absolute value. So it's like in an example here, 5 minus 3 is equal to 2, and 3 minus 5 equals to minus 2, right? But if you do abs on this absolute value, then it will be equal to 2. So we need that. That function is Arduino.h, Arduino's library's function, so we need Arduino library for that as well. Environment brightness is, well, it's, let's say, well, let me show you in here actually what it is. So this sensor, light sensor, reads values from 0 to 1000. If it's brighter, it's like 800, 900, maybe 1000, and if it's darker, it's around 100. So in here, don't look at this code, I will explain you later. I'm just now explaining the light sensor, this formula. Okay, so I do here for loop. I created an array here, and 10 elements. Its size is 10. So I here create a for loop that goes from 0 to 9. It will loop 10 times. And here I set array's 0th element to be equal to the value that sensor returns. So if you're in like bright room, it will be like maybe 700, 600, let's say 700. And remember that this will happen in a like maybe even less than second. So yeah, when you run the project, it will immediately get the environmental brightness, which in this case we said it's 700. So LDR set environmental brightness to be equal to average. Okay, so let me just say this, that we have the 10 values that sensor read it in this array now, because we loop through and set each element to read the sensor's read function, which is here, analog read. So now set environmental brightness. It will set environmental brightness to what this function returns, and this function returns so let me show that function, average. So this function is like basic. I will not explain you how the function works. It's not like, it's just taking average of 10 numbers, let's say 5, 7, 8, 10, 5, 3, 2, 11. How much is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 numbers. Let's like do it in calculator. 5 plus 7 plus 8 plus 10 plus 3 plus 2 plus 11 plus 15 plus 86 plus 23 equals, and then you divide this on to how many numbers there are, and in this case there are 10 numbers, so average of these numbers is 17. So that's what average means. So I'm in our case it won't be this these values are too little, so in our case it will be like, instead of 5 it will be 700, 701, 702, maybe 710, 698, because the sensor is not every time precious. I mean, it's not professional sensor. So we take the average of that last 10 values that we have read, and now we set it to environmental brightness. So let's say the average is 700. Now our variable environmental brightness is equal to 700 because we passed it in here. So environmental brightness 700, and when the car comes, it will be around 300. You can tested it a lot. So it will be around 300, maybe even 150, about 150, 200. So let's say 150. So let's see, what does this formula do? 700, so environmental brightness is 700 minus 150, and we read the 150 because we are giving an example that car came in front of I mean on top of the sensor, so it will be the shadow of the car, so it will be much more darker. As I said, it will be around 150. So we take absolute value of this, which is equal to 550, and we say return if 550 is if 550 is bigger than 120. It means it's actually like this. You can think of this code as this. It's the same thing. If 550 is bigger than 120, return 1, else return 0. It basically means that, but it's much shorter. So yeah. And I explained you now light sensor. Now the only one remained is distance sensor. Let me show you that one as well. So in distance sensor I use another library which does all the formulas and things, so you can use distance sensor. You can look that on Google and download. I will actually put all the libraries that I've used, all the code in description, so you can see, so you can download from there as well. Okay, so protected we have, okay, so you can Google distance sensor so you can understand better this model, actually this one, so you can understand better, but I will explain you briefly. So you have trigger pin, echo pin, and that's all actually from the ones that you will read values. Of course you have ground and 5 volts. Okay, and you have max distance, so that's my variable that I made, that is not related to the sensor pins. That's variable for so this new pin library needs to know what's the biggest distance you need to calculate. I mean, if you don't need bigger than 100 centimeters, if you're in this project, we don't need that. We need maybe 30 centimeters or something like that. We don't need too much distance. And there's current value and last value. Okay, I will show that in a second what that means. Okay, we have constructor. It has 3 parameters: trigger pin, echo pin, and max distance. So whoever is creating an object, he must pass in trigger pin, echo pin, and max distance. So in here, as you can see here, I passed in 3 values. So, and there's destructor. You can Google it as well. I will not explain it. Maybe briefly I will. Get trigger pin, get echo pin. So that just returns trigger pin, echo pin, and get max distance. It returns max distance, and set max distance. So where is set max distance? Okay, this one is not needed. Well, I actually made it, but then I changed my mind because you must have this in constructor, so we don't really need this function. Don't think of this function. Okay. Yes. And we have read, of course. Every sensor should have read. Almost every, I guess. So let me show you firstly constructor. So I set max member variable m max distance to be equal to max distance that whoever is calling this constructor made. The object, whoever passed in this value, it will be the m max distance will be equal to that. Trigger pin will be equal to trigger pin, echo pin will be equal to echo pin, and then I'm creating sonar. So I actually didn't explain this. I have here pointer. If you don't know what's pointer, you can Google it. I cannot explain it in this video. It's like big new section to be explained. So I have pointer on new ping object. So you must do it like this if you want to use any objects. I mean, maybe there's another way, but I do it as this. So I make pointer to new ping object, then, but this is for now just pointer. You cannot say you cannot use anything. It's not allocated to memory. So in constructor you must say sonar equals new ping. That's kind of funny. So the new is for allocating memory for class new ping, and you pass in the required parameters, which we have in this case: m trigger pin, echo pin, max distance, and we set current value and last value to be equal to 0 for now in constructor. And when here I call read, so read, I will call read to get distance. So how does that work? This is actually, I take this from example from internet. It just how to use the sonar library. So you just do as this. You can Google it. This model of sensor. So this means if current value is true, so if it's true, set last value to be equal to current value, and if it's not, set the current value to be equal to last value. Why did I do this? Because this sensor, for me at least, it's really problematic. It says it does read it reads like 5 centimeters, and suddenly it reads 0 for some reason. It's bad sensor actually, but it's most popular, so I didn't find any other sensors to use for distance. So I made something like this to make it a bit better. If the value is not 0, actually, this means if it's not 0, 0 in C++ is false as well, so it can be called as false. So this means if this variable contains true value, so that means if it's bigger than 0, or it can be less as well. If it's just not 0, if it's not 0, so if it's not 0, last value equals current value. So variable named last value equals current value. And if it's not, and if the value is like, let's say here, it will dive in if it's like 5, and it will set last value to be 5. But if it's not, then it will be 0. And else, if it's 0, it will come here and say current value equals last value. So let's do this. Let's give these values an example. Let's say current value is, let's say, 5 centimeters. So here reads 5 centimeters. And if current value is okay, then last value, now let's remember this, last value equals 5, right? And here is 5, 5, 5, so every time last value will be 5, and here will return 5. And let's say that bug happened, well, the sensor bug, I call it bug. So if he suddenly reads 0, current value will be now 0 centimeters. And I say here, if current value is true, well, 0 is false, so it's not true. It will come in here and say current value equals last value, which is 5. So it will keep on, like it will not return 0, but 5 instead. And I don't need in general 0 centimeter distance. It's like pointless to have 0 centimeter distance, so it will not be a problem to use like this. Sorry. So that's it from the libraries. Explain. Servo is not my library. I mean, I didn't make it, so you can Google it as well. So now we have global variables, distance and light value. So in setup, well, I explained this. I have an array because I want to take an average of last 10 numbers and set it to environmental brightness. Okay, so serial.begin. This is for printing something or writing something on serial monitor. Basically to use serial ports. So I'm using this right now to just print values. Actually, I'm in this project you don't even need this, but this is testing purpose. So I did that for test, but I don't use it anywhere. So you can delete this if you don't want this. then we have red LED set pin to 7. So as you can see in here, red LED. So red LED's ground is on ground, and its longer like pin, what's that called, is on 7th pin, as you can see. So I'm telling it to be 7. Green LED, I set it to, let's go from here to 6. I did for some reason. Oh, I moved that on my Arduino, but let's say it's 8 for now. Okay, 8. And oh, I didn't show you this. In this example, we use. I was testing this, so it's 3 and 2, but I will set it as these pins. So the trigger pin is 6, as you can see, and echo pin is 5. So I'm setting trigger pin. Oh, sorry. So trigger pin, echo pin, distance, maximum distance. So trigger pin is 6, echo pin is 5, and max distance is 50. So red LED is 7th pin, green LED is 8, and LDR is 0. It's actually you can write A0 as well, analog 0. You can write 0 as well. So as you can see, where is it? Oh, I didn't move it. I will move it to 0. Sorry. So it's on 0. And this wiring needs some adjustments. I will show you. This is wrong for now. I will show at the end of the video how I will fix this. I changed this. I thought it was like this, the LDR, but its wiring is different than this. I will show you later. So gate servo attach. This is same as my set pin function, but the guy that made this library called it attach. So it sets pin to be 9. I set to be 9 because, as you can see, the servo's pin is on 9th pin. I explained you this earlier. So in the loop we have distance. Well, we have distance here, but we use distance in here. We initialize it to be the value that is read from sensor. So it will be like 7, 7, 7, 7, 7 until the car came, and when the car came it will be like 2. So when it changes like to 2, 3, 4, 5 maybe, we can know the car came in. So the gate needs to be open. So if LDR.get status, so this means if it's equal to 1, because 1 in C++ is equal to true. I mean, it's used as true. So you can say here 1 or even true, I guess, like this, or maybe even high, because Arduino has high as true. Okay, but we'll for now use like this. So if it's true, so if there's a car parked, so if the car came in, actually car came on top of this sensor, the light sensor. So when it came on top of light sensor, the value will change as we showed in here. We did an example. So when that happens, when the car is parked. So when it's parked, we here set the green LED to be off. So there is so if there's a car, it's not free, the place to be parked, so there's no green. And the red LED is turned on, so that means the LED is now turned on, the red LED, so that means the place is full, you cannot enter. And gate servo we want it to be 0. So this is related to how you put your servo. It can be 19 degrees, maybe even. It's related how you put your servo. In my case, I just did 0. So this means it's gate, close gate. So if the status is not changed, so if there is no car on top of the light sensor, then red LED is off and green LED is on. So that means if there is no car parked, then it's free. So red LED is off and green LED is on. And you here can say now distance. So the distance we read. So let's say we have two cars. One car is parked and another is waiting to enter, like in front of gate. So because car is parked, it will enter here and the servo, i.e. the gate, will not open. Okay, but if that car that is parked leaves the park, then the car that was waiting in front of gate will actually get the gate open, so it can, like enter. Because in here we say distance, so because there's car in front of gate, distance is like maybe 3-4 centimeters, or you need it to set to be 3 or 4 centimeters. If you want more, you can put here like 15, so it's up to 15 centimeters, but it's, I guess, too much. Okay, I set it to be 6. So gate servo dot right. So this basically means right means as in here. It means to set the servo on. This is degrees. Let me show you the function. Okay, so this is the library. It sets it to 0. Here it says to 90 degrees, and if it's less than 6 or equal to 6, so if the car is there in front of gate, and in this case it is, then open the gate, close the gate. If there is no, close the gate. So if there is no car in front of the gate, then close the gate. And actually it's like everything that's decoded, all the code I explained it. So now I will explain the wiring in detail and fix the issue in here with LDR wiring, light sensor wiring. So, and just let me explain again get status, because I have a feeling that I didn't explain it really well. So just let me explain it again. Get status is the environmental brightness you have. So we said it's like 600 if you're in brighter room, or 700, never mind. And the read is like when the car is there, it's like 200. If this is bigger than 120, okay, so this is 500, so it returns, sorry, so yeah, so 500 is bigger than 120, so it returns true. So in here it will enter this one. So the car is there because car is there. Because car is there, it should do like close the gate. It should turn the red LED on and green LED off if the car is on top of the light sensor. I parked. So this indicates that. Wait a second. And if, let's say, the car moved, so now the read is like 700 maybe, or yeah, 700. So if 500 is bigger than 700, well, it's not, so it will return 0, and it will return 0, and it will then enter this, which means the car is not on top of the light sensor, it's not parked. So now the car that was waiting in front of the gate, it can enter. Okay, I guess I explained it good. Now we have wiring here. Okay, so now let me just, I will just need to fix this LDR. So this is now fixed, the wiring of LDR light sensor. So I just want to before explaining this all, I want to say you that the black wires in general represent minus, and red wires represent plus. And just to say you that this software's name is Fritzing, so you can download it, it's really cool. You can Google on Fritzing. Okay, so here let's explain from the beginning, from LEDs. So we have green LEDs and red LED. So there is the LED, normal LEDs generally have the long leg, let's say leg, yeah, and short leg. So the long one is this one, the right one, and the short one is the left one in this case. So as you can see here, in the generally in long at long leg we put plus or the pin, and on the short leg we put minus, ground. So as you can see on short leg it's minus in here, and long leg is on 8th pin, same here, except the pin is 7 at the red LED. So short leg is on minus, ground, and long leg is connected to 7th pin, as in the code. So if you want to learn how breadboard works, there are a lot of tutorials on YouTube, so you can just look that one and then come here and see what's going on. You can understand better, maybe. If you know, you just can keep up with the video. So and we have like 5 volts in here on this line, it's 5 volts, and ground is on this line. So here this line is ground, That's how these take ground from the line. From the Arduino. And sensor has pins. This one is plus. The 5 volts. So it's wired in here in this line, and that goes to 5 volts. Then trigger pin is on 6th pin, and echo pin is on 5th pin. We saw that in the code as well. And the ground is on ground in Arduino. See this line. So and LDR light sensor. You need to wire it like this. I really am not sure why. I'm not really into electronics. But just you need to know that it doesn't, on the photocell eye, the light sensor, it doesn't makes difference. There is no like long leg, short leg. So let's say right leg, left leg. Let's say in this example right leg. So in there you put one resistor, and at the other leg of the resistor you put the ground you connect with that one, and on the other leg of LDR you connect 5 volts, and on the first leg you connect to the pin as well. So that's analog 0. So that's how you connect the LDR. And here we have servo motor. So as I said, red represents plus, and black represents ground. It's minus. So in here, this is plus, this is minus, and this is the pulse. That's like the where it reads value from. It gives value. So the pin. So you connect the pin there on the yellow wire. So we connect it on nth pin. The 5 volts go to it's not actually 5 volts in this case, it's plus, but it goes to in here. This one needs to be 7 volts, some external power source. So you need to have like something like this, 7 volts, and it's connected to like the plus from servo is connected to 7 volts from this battery pack, and the ground is connected as well on the battery pack. And at the same line where the servo's ground is connected to battery's ground, there's Arduino's ground as well connected. It must be like that, so keep that in mind. And that's all, I guess. Yeah, that's all. So if you like the video, if it's helpful, please subscribe. Thank you.